The year is 1921, and the United States military is conducting a comprehensive review of the weapons, tactics, and equipment employed during World War I. The American Expeditionary Forces have returned from France with hard-won experience about what works and what does not work in modern industrial warfare. Among the weapons being scrutinized is the M1911 pistol, John Browning's masterpiece of handgun design, adopted by the U.S. military in 1911 and proven in combat from the trenches of France to the jungles of the Philippines. The M1911 has performed admirably as a sidearm for officers, vehicle crews, and support personnel. But some ordnance officers and weapons developers are asking a different question. What if the M1911 could be more than just a sidearm? What if it could be transformed into a primary weapon with firepower approaching that of submachine guns? This question leads to one of the most ambitious and ultimately impractical experiments in American firearms development, the attempt to create a high-capacity drum magazine for the M1911 pistol. The concept envisions transforming the 7-round sidearm into a weapon holding 40 rounds of .45 ACP ammunition, capable of sustained fire that would give individual soldiers firepower density far exceeding what standard pistols could provide. The engineering challenges are immense, the practical complications are numerous, and the resulting experimental weapons reveal much about the gap between theoretical capability and tactical utility. The M1911 pistol operates via a short recoil tilting barrel action that has become one of the most copied and influential handgun designs in history. When fired, the barrel and slide recoil together for a short distance while locked by lugs. The barrel then tilts downward, unlocking from the slide. The slide continues rearward, extracting and ejecting the spent casing, cocking the hammer and compressing the recoil spring. The spring then drives the slide forward, stripping a fresh cartridge from the magazine, pushing it into the chamber and allowing the barrel to rise and lock with the slide again. This action is smooth, reliable, and proven across millions of rounds fired in countless conditions. The standard magazine is a single-stack design holding 7 rounds of .45 ACP ammunition inserted into the grip and feeding cartridges upward into the chamber. Creating a 40-round drum magazine for the M1911 requires abandoning almost every aspect of the standard feeding system. The magazine well in the grip is sized for the 7-round magazine. There is simply no way to fit 40 rounds of .45 ACP ammunition into that space using any remotely practical design. A drum magazine must therefore mount externally, likely below or beside the pistol, connected via an adapter that interfaces with the existing magazine well, or via a completely redesigned lower receiver that accepts drum mounting systems. Both approaches present formidable engineering challenges. The .45 ACP cartridge is substantially larger and heavier than most pistol cartridges. Each round is approximately 1.27 inches in overall length and weighs about 21 grams. 40 rounds represent approximately 1.9 pounds of ammunition alone, not counting the weight of the magazine body, spring mechanism, and feeding system. A loaded 40-round drum magazine for the .45 ACP would weigh close to 3 pounds, more than the entire weight of a standard M1911 pistol. Attaching this weight to a handgun designed to weigh approximately 2.5 pounds loaded with a 7-round magazine creates a weapon system weighing over 5 pounds, with the weight distribution completely altered from what the pistol was designed to handle. The feeding mechanism for a 40-round drum presents its own complications. Drum magazines for pistol cartridges are notoriously difficult to design reliably. The Finnish Suomi and the Thompson submachine gun both employed drum magazines with varying degrees of success, but these were for 9mm parabellum and .45 ACP respectively, in weapons specifically designed with drum feeding in mind. Adapting drum feeding to a weapon designed for single-stack box magazine feeding requires either creating an adapter that translates the drum's feed position to the pistol's magazine well, or completely redesigning the pistol's lower receiver to accept direct drum mounting. Either approach requires extensive engineering and introduces multiple potential points of failure. The experimental work proceeds at various facilities during the early 1920s. Multiple approaches are explored by different designers and ordnance teams. Some experiments focus on rotary drums, similar to the Thompson's 50-round and 100-round drums, using spiral tracks and spring-driven rotation to advance cartridges. Other approaches explored different geometries, casket magazines, quad-stack magazines, and other high-capacity designs. The goal in all cases is to determine whether it is possible to create a reliable high-capacity magazine for the M1911 and whether the resulting weapon system offers tactical advantages worth the complexity and compromises. Test weapons emerge from these programs. Ordnance records and surviving photographs document M1911 pistols fitted with various experimental drum magazines. These weapons look unusual to the point of absurdity, the elegant lines of the M1911 disrupted by massive drum magazines that dwarf the pistol itself. The visual proportions are all wrong, with the drum appearing to be the primary component and the pistol merely an attachment for firing it. But appearance is less important than function, and the experimental weapons undergo extensive testing to evaluate their performance. The feeding reliability proved problematic from the start. The M1911's tilting barrel action was optimized for feeding from the straight vertical presentation of cartridges in the single-stack magazine. Cartridges arrive at the feed ramp at a consistent angle and with consistent spring pressure. Drum magazines present cartridges differently. The feeding angle varies as the drum rotates or as cartridges traverse the feed path from drum to chamber. The spring tension may be inconsistent depending on how many rounds remain in the drum and the specific geometry of the feeding mechanism. Each of these variations from the standard feeding geometry creates opportunities for malfunctions. Testing reveals feeding failures occur with distressing frequency. Cartridges jam at the feed ramp, failing to chamber properly. Rim lock occurs, where the extractor rim of one cartridge catches on another. Double feeds happen when the feeding mechanism presents multiple cartridges simultaneously. These malfunctions occur even under ideal testing range conditions, with clean weapons and fresh ammunition. In field conditions, with dirt, temperature variations, and worn components, reliability would almost certainly be worse. The weight and balance issues prove even more problematic than anticipated. A 40-round drum adds 3 pounds to the M1911, but this weight is not evenly distributed. Depending on where the drum mounts, below the pistol, beside it, or in some other configuration, the center of gravity shifts dramatically. A drum mounted below the pistol makes it extremely muzzle-heavy, with the weight pulling downward and forward. This affects how the pistol points, how it recoils, and how much strength is required to hold it steady for aimed fire. Soldiers testing the experimental weapons report that extended firing sessions are exhausting, that the weight makes accurate shooting difficult, and that the drum's bulk interferes with normal shooting stances and grip positions. The physical dimensions of the drum create handling problems that become apparent during actual use trials. A 40-round drum for .45 ACP ammunition is necessarily large, several inches in diameter, regardless of the specific geometry employed. This bulk interferes with how the pistol can be holstered, carried, and deployed. Standard holsters obviously cannot accommodate a drum-equipped pistol. Specialized carriers must be designed, and these are invariably bulky and awkward. Drawing the weapon from a holster or carrier requires different techniques than drawing a standard pistol, and these techniques must be learned and practiced. The drum catches on clothing, equipment, and environmental obstacles in ways that standard pistols do not. Reloading the drum magazine presents challenges similar to those encountered with other drum-fed weapons. 40 rounds of .45 ACP into a drum mechanism takes time, 5 to 10 minutes for careful loading by someone familiar with the specific drum design. This loading process must be performed in advance. Reloading an empty drum during combat is completely impractical. The tactical employment doctrine would therefore require soldiers to carry multiple loaded drums, treating them as semi-disposable once emptied. But 40-round drums for .45 ACP are large and heavy. Carrying 3 or 4 of them along with the pistol and all other combat equipment creates a load that quickly becomes unrealistic for individual soldiers to manage. The question of tactical utility becomes central to evaluating the experimental drum-fed M1911. What specific combat situations require a pistol with 40-round capacity? Proponents argue that vehicle crews, military police, officers, and support personnel might benefit from a compact weapon with sustained fire capability approaching that of submachine guns. A tank crew member or truck driver equipped with a drum-fed M1911 could defend their vehicle with firepower exceeding what a standard pistol provides. Military police conducting security operations might benefit from extended capacity without needing to carry rifles or submachine guns. But critics point out that every tactical role the drum-fed M1911 might fill is already filled by existing weapons that perform better. The Thompson submachine gun provides fully automatic fire with drum magazines holding 50 or even 100 rounds. The M1 carbine, which enters development during this same period, will provide semi-automatic fire from a compact, lightweight rifle with 15 or 30-round magazines. Both weapons offer superior firepower in more practical packages than a drum-fed pistol. Where exactly does the drum-fed M1911 fit in the weapons lineup? What specific mission requires its specific combination of pistol-sized package and drum magazine capacity? The inability to answer these questions convincingly leads to the program's gradual abandonment. By the mid-1920s, active development of drum magazines for the M1911 has largely ceased. The experimental weapons are placed in storage or relegated to curiosity status. Resources that might have gone toward continued development are redirected to other projects that show more promise or address more clearly defined tactical needs. The drum-fed M1911 joins the long list of experimental weapons that were tested and found wanting, not because they did not work at all, but because they did not work well enough to justify the costs and complications they introduced. The few surviving experimental drum-fed M1911 pistols exist today primarily in military museums and occasionally in the collections of serious firearms historians. Original 40-round drums for the M1911 are extraordinarily rare. Most were destroyed when the programs were terminated, and the few that survived are valued more for their historical curiosity than for any practical utility. Collectors who encounter these items understand that they represent a moment when developers explored the absolute limits of what a pistol could be, pushing the design envelope far beyond where practical considerations suggested it should go. The story of the experimental 40-round drum magazine for the M1911 illustrates several important principles about weapons development. First, it demonstrates that capacity alone does not determine tactical utility. 40 rounds sounds impressive compared to 7, and in pure numerical terms, it represents a significant increase. But this capacity increase comes with costs: weight, bulk, complexity, reduced reliability, handling difficulties that may exceed what the capacity gain is worth. A weapon with 40 rounds that is awkward to carry, difficult to shoot accurately, and prone to jamming may be less useful in actual combat than a weapon with 7 rounds that is reliable, easy to handle, and can be fired accurately under stress. Second, the story reveals the importance of considering the complete weapon system rather than just individual components. A drum magazine might work adequately in isolation, feeding cartridges reliably on a test bench, but when integrated with a pistol designed around completely different feeding geometry, when carried by soldiers along with all their other equipment, when employed under actual field conditions, the system-level problems emerge. The M1911 with retrofitted drum magazine was attempting to force a feeding system onto a weapon never designed for it, and the results reflected this fundamental incompatibility. Third, the experimental drum-fed M1911 demonstrates the value of exploring ideas even when those ideas ultimately prove impractical. The engineering work required to create functioning drum magazines for the 45 ACP cartridge generated knowledge about magazine design, feeding geometry, and the limits of adapting existing weapons to radically different feeding systems. This knowledge informed subsequent development work, even though the specific drum-fed M1911 configuration was abandoned. Engineers learned what did not work and why, and this negative knowledge is valuable because it prevents future wasted effort on similar unpromising approaches. The contrast between the experimental drum-fed M1911 and weapons that did succeed is instructive. The Thompson submachine gun used drum magazines, but the weapon was designed from the beginning with drum feeding in mind. The action, the receiver geometry, the overall weapon architecture, all were optimized for drum feeding. The result was a weapon that, while having its own issues with drum magazine reliability, at least functioned adequately for its intended purpose. The M1911 with retrofitted drum magazine was attempting to force a feeding system onto a weapon never designed for it, and the results reflected this fundamental incompatibility. Modern firearms enthusiasts sometimes encounter references to drum-fed M1911 pistols in ordnance documents or see photographs of the experimental weapons and are intrigued by the unusual configurations. The weapons occupy a space in firearms history as curiosities, as examples of experimental dead ends, as evidence of how far developers were willing to push the boundaries of conventional weapon design during the interwar period, when tactical requirements were being reassessed and weapon technologies were evolving rapidly. Some modern manufacturers have created aftermarket high-capacity magazines for the M1911 and similar pistols, including some drum configurations. These modern drums benefit from materials, manufacturing techniques, and design knowledge unavailable in the 1920s, yet they still tend to be heavier, bulkier, and less reliable than standard magazines. The fundamental challenges of creating reliable, high-capacity drum magazines for pistols remained largely unsolved even with modern technology, highlighting just how difficult the problems that 1920s engineers were attempting to address actually were. The M1911 itself, of course, went on to become one of the most successful and longest-serving military pistols in history. It remained the standard U.S. military sidearm from 1911 until the mid-1980s, serving in World War I, World War II, Korea, Vietnam, and numerous other conflicts. The standard 7-round magazine, later increased to 8 rounds in some variants, proved entirely adequate for the pistol's actual tactical employment. Soldiers carrying M1911s were not clamoring for 40-round drums because the situations where a sidearm was needed were situations where 7 or 8 rounds were sufficient. When more firepower was needed, soldiers used rifles, carbines, submachine guns, or machine guns, weapons designed to deliver sustained fire rather than pistols awkwardly modified to approximate that capability. The abandonment of the drum-fed M1911 program represents sound decision-making by military authorities. They explored an idea, tested it thoroughly, gathered data on its performance and limitations, and made the rational determination that despite technical feasibility, the concept did not offer sufficient tactical advantages to warrant production. This process, propose, test, evaluate, decide, is exactly how weapons development should function. Not every idea that can be engineered should be produced, and the ability to recognize this and redirect resources accordingly is as important as the ability to develop new weapons in the first place. The abandonment of the drum-fed M1911 represents sound decision-making by military authorities. They explored an idea, tested it thoroughly, gathered data on its performance and limitations, and made the rational determination that despite technical feasibility, the concept did not offer sufficient tactical advantages to warrant production. This process, propose, test, evaluate, decide, is exactly how weapons development should function. Not every idea that can be engineered should be produced, and the ability to recognize this and redirect resources accordingly is as important as the ability to develop new weapons in the first place. The legacy of the experimental drum-fed M1911 is one of ambitious innovation that exceeded practical bounds. Engineers proved that it was possible to create drum magazines that would physically attach to an M1911 and feed .45 ACP ammunition. But possibility is not the same as practicality, and the experimental weapons revealed that this particular configuration created more problems than it solved. The weight was excessive, the bulk was prohibitive, the reliability was questionable, and the tactical niche was either non-existent or already filled by better weapons. When they put a 40-round experimental drum magazine on a standard M1911 pistol, they created a weapon that was technically functional but tactically dubious. They demonstrated the outer limits of what drum feeding could be adapted to, and in doing so, they identified where those limits should not be exceeded in production weapons. The experimental drum-fed M1911 worked just well enough to prove it should not be built, and that knowledge, the knowledge of what not to pursue, is itself valuable, even if less celebrated than the knowledge of what to develop. The story serves as a reminder that in weapons development, as in many engineering disciplines, knowing when to stop is as important as knowing how to start. The experimental drum-fed M1911 was started, pursued through testing and evaluation, and then stopped when data indicated it was not worth continuing. No production models were built, no soldiers were issued weapons that would frustrate them with bulk and unreliability, and resources were preserved for developments that actually improved combat effectiveness. In the final analysis, this represents success, not failure. The success of a functional evaluation process that protected soldiers from being equipped with weapons that looked impressive on paper but would fail them in combat. The 40-round drum magazine for the M1911 pistol exists today primarily as a historical footnote, a curiosity that firearms historians discuss and collectors occasionally encounter in museum displays.